Hi, how's it going? In this video I'm going to look at algebraic long division, or some of you might know it, polynomial long division, okay? But I like the word algebra. Algebra is a really cool mathematical sounding word, don't you think? So, because I like algebra so much, I call it algebraic long division, okay? There you go. We can't argue because it's my video, of course. But some of you might know it as polynomial long division. Or what actually is it? It's used in long division with algebra, basically. Okay, so for example, you've got an algebraic expression here, or a polynomial, x cubed plus 2x squared subtract 17x plus 6, and we want to divide that by x minus 3. Why do we want to do that? Well, maybe later I'll show you, okay, but for the moment just go with it. Sometimes you want to be able to do these things, okay. What I'm going to do is I'm going to remind you how to do it with numbers, okay. So instead, I'm going to come back to that, and we'll look at doing the same thing but with numbers, because numbers is always easier to understand to begin with, isn't it? So I'm going to look at dividing 13,482 by 14 to begin with. Okay. Now, if you could use long division, the way you'd set it out is like this. Okay, so I'll put 1, 3, 4, 8, 2, just space the numbers out a little bit. Okay, and divide that by 14. That's normally how we'd set out our working for long division. Okay. And the first step is to see how many times 14 will go into 1, well, it doesn't go. So then we combine these two. How many times 14 goes into 13? Again, it doesn't go. So we'll combine these three. How many times 14 goes into 134? Oh, 14 will go into 134, so we can actually write that down. And it goes 9 times. And we write the answer 9 up there, okay? Now in long division, what we then do is we see what 9 times 14 actually is. Because if you think about it, we probably had to work that out in order to see how many times 14 goes into 134. Okay. Well, 10 times 14 is 140, so subtract 14, it's 126. Now I'm going to write 126 underneath like that. And then what we do is we find the difference, or what we literally do, and it's a good idea to think about this for when we come to the algebra. Okay, what we literally do is we do this subtract this. Okay. Now we know 134 subtract 126 is 8, so we can just write that in. It's 8, like that. Okay. Notice I'm trying to line up the relative units. Okay, so that's the units column of that number. So I put the 8 there because that's we'll go in the units column, wouldn't it? If it was 18, I'd put it like that. Okay. Right, what do we do next? Well, now we move along and we bring this value down. Okay, so that becomes 88. We can see how many times 14 will go into 88, okay? And that is 6 times. So because it's 6 times, I'm going to put the 6 up there, okay? And then next I'm going to work out what 6 times 14 actually is. That is 84. And I'm going to write the answer there. And then we do the same thing over again. We find the difference, or literally do that, subtract that, which gives us 4, okay? And then we bring the last value down. And we start again. We do 14 into 42. How many times does that go? That goes 3 times. Okay, but we don't actually end there. Okay, it's rather importantly because there could be remainders. So I'm going to continue with that. We do 3 times 14, and the answer goes down by here, which is 42. And then find the difference, 0. That bit is important because the 0 there is telling us there's no remainder. Okay, that would be important when we do the algebra. So what that means is when we do 13,482 divided by 14, we get an answer of 963. Okay, so I could write the answer like this: 13,482 divide by 14, that is equal to 963. Okay, that's it. That's it with numbers. Let's have a go at the same thing but using algebra now instead, shall we? So what I'm going to do is I'm going to keep that there. I'm just going to rub this off, and hopefully I'll have enough space to be able to fit in the algebra. Okay. Remember, one of the key words is long, so it's long. Okay, so you've got to make sure that you've left enough space in your workbook. Don't start right at the end of your notes page. Make sure you've got plenty of space to be able to do it again. We're going to do this divided by this. Okay, so I'm going to put the x minus 3 here, and then put in this here. Some people call that the bus stop, by the way. If you lived in the UK, you'll appreciate that. I don't, but I've heard some people in the classroom call it a bus stop before. Okay, maybe it comes from primary school. I don't know. Yeah, so set it out exactly the same way. You see, so we'd have that divided by 14, and we got that divided by x minus 3. Okay. Now, the thing to do to make this easier is rather than look at x minus 3. divided into any of these terms, we're going to look at the largest term in this x minus 3, which is x. Okay, that's the largest value out of x and and 3 and negative 3. Okay, so we do x and see how many times that goes into x cubed. Okay, I'm going to say it one more time. We're going to see how many times x goes into x cubed, or put more simply, what do you multiply x by to get x cubed? Okay, what do you multiply x by to get x cubed? We multiply by x squared, and we write that answer up here. Okay. Now, just as I said earlier about trying to get numbers in alignment, okay, with the tens, units, and hundreds, and so on, it's imperative that you line up all the cubic terms, square terms, linear terms, and numbers all together. Okay, and you'll see why as we go through it. Okay. And then what do we do next after you've got the 9 here? We did 9 times 14 and wrote the answer here, so we do exactly the same thing again. We're going to do x squared multiplied by all of this. So x squared times x is x cubed, and x squared times negative 3 is negative 3x squared. Okay, and then what do we do here? We found the difference. Okay, so we do the same again, but literally what you're doing is you're doing this, subtract this. Okay, so we do it term at a time. So x cubed subtract x cubed is 0, and then 2x squared subtract negative 3x squared is 5x squared. Remember, you're doing 2 subtract negative 3, which is the same as 2 plus 3, so 5x squared. What did we do after we had the 8 there? We brought this value down, so we do the same again here. We're going to bring the negative 17x down, and then we start all over again. Okay, we start all over again. We did 14 into 88 and wrote the answer up there. Okay, only what we do is we look at the largest value term, x, and we see how many times that goes into the largest value term here, 5x squared. So how many times x goes into 5x squared? Or, put simply, what you multiply x by to get 5x squared. It's 5x, okay? Because it's positive 5x, we write plus 5x there, okay? And then what do we do? Well, here what we do is we did 6 times 14 and wrote the answer in. We'll do the same here, 5x times x minus 3 and write the answer in. So 5x times x is 5x squared. Incidentally, notice every time you do these two will be exactly the same. If they're not, you've done it wrong somewhere, because these have got to cancel out. Because basically what's happening is the powers are diminishing as you go through the long division process. Okay, so 5x times x is 5x squared, 5x times negative 3 is negative 15x. And then we find the difference again, and 5x squared subtract 5x squared, you see, is 0. Negative 17x subtract negative 15x, so negative 17 plus 15 is negative 2x. Okay, and then we bring the last term down, plus 6, okay, plus 6, and then we start again. How many times x goes into negative 2x, or what we multiply x by to get negative 2x, and that is negative 2, isn't it? Okay, and then what we do is we do negative 2 times this. I hope you've finished with that now, because I'm going to have to rub it off. As I said, one of the things about long division is in the title, it's long. You need a fair bit of space to be able to fit it in, but I hope you've got the general idea now of the numbers. Okay, I only left it there for a sufficient amount of time so you could kind of compare the two and see what was going on. Okay, so we've got the negative 2 there. Remember, the next thing is to do negative 2 times by x minus 3, so that's going to be negative 2x. Remember, those two should always be the same, otherwise you've messed it up, and negative 2 times negative 3 is positive 6. Okay, remember what I said about the final bit? Okay, if you find the difference between them and you get 0, that means there's no remainder. Okay, this is a simple example, there's no remainder, but in other questions there could be a remainder. Okay, there's no remainder. So what that means is when you divide this by x minus 3, you get x squared plus 5x minus 2. Okay, now let me show you another way of rewriting the question. So we've got our polynomial x cubed plus 2x squared subtract 17x plus 6. Okay, yeah, we've got our polynomial. When we say divide by x minus 3, we can write that more simply as a fraction, can't we? Okay, so that is a shorthand way in algebra of writing x cubed plus 2x squared minus into x plus 6 divided by x minus 3. Okay, and what we got as our answer, so equals, is this: x squared plus 5x minus 2. Okay, so what we've gone and done is we've simplified this algebraic fraction. Okay, and that's one of the usefulnesses of algebraic long division, is to be able to simplify algebraic fractions if they can be simplified. Okay, so we've written this as this instead. Okay, now I'm going to write that in another way. What I'm going to do is this. I'm going to keep the numerator x cubed plus 2x squared minus 17x plus 6. And what I'm going to do is I'm going to bring the x minus 3 over to that side there. In other words, multiply both sides by x minus 3. So I get x minus 3, x squared plus 5x minus 2. Okay, so you'll agree that that is a true statement as well. Can you see what we've gone and done is we've shown how that cubic can be factorised. Okay, we've shown how that cubic can be factorised. Okay, which is what this question could also be about as well. As long as there's no remainders, it will factorise perfectly. Okay, so we've shown that x cubed plus 2x squared minus 7x plus 6 is factorisable with x minus 3 as one of the factors, and the other factor is x squared plus 5x minus 2. So long division is rather handy for being able to factorise cubic expressions as well, or quartic expressions or quint expressions. However, you do need to have what one of the factors is to be able to get going. Okay. Well, I'm hoping that you found that simple example useful for you as an introduction to long division. Coming up are some more examples for you. Okay, next example. So divide 2x cubed minus 5x squared, subtract 16x plus 10 by x minus 4. Okay, so what we do is we set it out like this. So I'm going to put the x minus 4 there. I call it a dividing bracket. Okay, and then inside that 2x cubed, subtract 5x squared, subtract 6x plus 10. Okay. Maybe you have a go at that one, you pause the video and just see how you get on, and then unpause the video and just see if you're correct. Okay, hope you've done that, or if you're just still watching, never mind, not much I can do about it, is there? Right, so what do we do? So the first thing to do is to see how many times x goes into 2x cubed. Okay, so what you've got to multiply x by to get 2x cubed. That's 2x squared. Remember what I said about lining up the like terms, so make sure you line up all the cubic terms, square terms, linear terms, and the constants. Okay, so we've got 2x squared there, and then we do 2x squared multiplied by x minus 4. Okay, so that's going to give us 2x cubed, and then this time this, subtract 8x squared. Okay, and then we find the difference between these two. So this subtract this, always 0, otherwise you've got it wrong. And then this subtract this. This is where the vast majority of errors occur, to be honest, when you're subtracting with negatives. Okay, so make sure that you're. And I know it's long, and you probably will just want to get through it as quickly as possible, but it really messes up your question if you get it wrong. Okay, so make sure you're paying full attention to it. You're focusing. So -5 plus 8. So it's 3x squared. Okay, and then we bring this next term down, so let's bring down the -16x. And then we start all over again. Okay, so x into 3x squared, or what you times x by to get 3x squared. So that's going to be 3x, and that's positive 3x of course, so plus 3x, and then 3x multiplied by all of this, so that's going to be 3x squared. Again, those two are the same, otherwise you've messed it up. And then this times this is -12x. And then find the difference between them. This subtract this is 0, of course. -16 plus 12 is -4. So that would be -4x. And then bring down the last term, bring down the plus 10. And then x into -4x, that's going to be -4, isn't it? Yeah, -4. And then -4 multiplied by this. So of course the first term is -4x. And then -4 times -4 is positive 16. Ooh, that's a little bit different, that one, isn't it? Okay, can you see, hopefully, when you do the difference this time, you don't get 0. You don't get 0. Well, you've got to write down what it is. You get, that's 0, obviously, but 10 subtract 16, you get -6. What that means is there's a remainder of this question, okay? And sometimes we write the remainder like this, okay, r -6. Remember that from primary school? So in other words, our answer is, when you do this divided by x minus 4, we get 2x squared plus 3x minus 4, remainder negative 6. Okay? Or you write down underneath, therefore answer is 2x squared plus 3x minus 4, remainder negative 6. Okay? Now going back to the previous example, when we had 0 there, obviously it doesn't make sense to write remainder 0. Okay, because that means there's no remainder, hence there's no need. So when that value is not 0, whatever it is, and sometimes it's algebraic, okay, it doesn't always have to be just a number, but whatever that is, you write that down as your remainder. Okay. Now what I'm going to do is I'm going to write out the question another way. So we've got the cubic, 2x cubed minus 5x squared, subtract 16x plus 10, write it down correctly, yep. And what we're doing, of course, is we're dividing that by x minus 4. Okay, do remember that this means exactly the same as that, except this is the preferred way of writing it. It's shorthand, it's written as a fraction. That's what a fraction actually means. Numerator divided by the denominator, okay? And we can write that like this, you see. And the answer is, let's see if I can fit it on, 2x squared. Do you know what? I can't fit it on. So rather than get to the end and try and squeeze it on, I'm going to write the answer underneath. Okay, hope you don't mind. So the answer is 2x squared plus 3x minus 4. Okay, remainder negative 6. Okay, so you can put remainder negative 6, but I'm going to show you a better way of writing that. Okay, I'll show you a better way of writing that. What do we normally do with remainders when we're dividing? When I say normally, just whenever you're dealing with numbers, okay, you divide with numbers. What do you normally do with remainders? Okay, what you do is you write your answer as a fraction of the original divisor. Okay, so what I'm saying is we're going to write a remainder of negative 6 like this: negative 6 over what we're dividing by, x minus 4. Okay, let me just show you another example as to why it works. Okay, suppose you wanted to do 13 divided by 4. Okay, well obviously 13 divided by 4, it goes 3 times, and there's a remainder of 1, isn't there? Okay, because you've got 12, remainder of 1 to get the 13. You don't write your answer as 3, remainder of 1. Okay, what do? You write it like this, write it as a quarter. What we're doing is we're putting our remainder as a fraction of what we're dividing by. Okay, let me show you another one. So 12 divided by 5. Okay, well obviously 12 divided by 5 goes 2 times, but then there's a remainder of 2, isn't there? Okay, because 10 plus 2 makes it 12. What do we do with that 2? We write it as a fraction of what we're originally dividing by. Okay, write the remainder as a fraction with the divisor. Okay, and that's all we're doing here. Okay, we're writing our remainder, negative 6, as a fraction. Okay, from what we're originally dividing by. So yes, you can write that as your answer, but actually that is the better way of writing it. Okay, why is it the better way of writing it? Because what we've done is we've simplified this fraction. Okay, this is what we call a top-heavy fraction. Okay, or an improper fraction, or a vulgar fraction. Any of those terms will do. Improper is probably the best one. Okay, improper is probably the proper title. Sorry, the poor pun. What we want to do is we want to sometimes simplify that. Or why do we want to sometimes simplify improper fractions? It's because sometimes we can do things, we can do more things with fractions that are written like this. Okay, so for example, partial fractions when it comes onto it. Okay. Anyway, I'm hoping you found that example useful. It's more of an example of what to do with when you get a remainder, okay, but also why we're actually interested in, because we like to be able to simplify it in proper fractions sometimes. Okay. Another example coming right up. Okay, so look at this example then. So we need to divide 4x to the 4, subtract 17x squared plus 4 by 2x plus 1. Maybe pause the video and see how you get on. Okay. Well, if you've done that, and if you've not seen this type of example before, I wouldn't bet you got into a bit of a mess. Okay, let's have a look to see why that is. So let's put the 2x plus 1 there, outside the dividing bracket. Then inside we've got 4x to the power of 4. Now notice that even though this is a slightly higher order polynomial, because it's power 4 this time, there's no cubic term there, there's no linear term there either. Okay, and remember what I said about trying to make sure that you line up all the like powers? Okay, you've got to line up all the power 4 terms, power 3 terms, power 2 terms and so on. If you don't, then you get into a mess when you're doing the subtraction. Well, the trouble is, if there's no cubic term there, then that messes things up for us. So what we need to do is we need to fill in a cubic term, and the thing to do is to put plus 0x cubed, and then it'll work out nicely for us. And then we put in this subtract 17x squared. There's a linear term missing, so we'll fill it in like this, plus 0x, and then we'll put in the plus 4. Now we're ready to go, you see, because now we've got power 4 terms, power 3, power 2, power 1, and the constant term. We can line the powers up nicely and do the subtraction. So if you got it wrong first time, maybe pause the video again and have another go using this as your template. Right, now let's go through it and see if you got it right. Okay, so what times 2x gives us 4x to the power 4? That is 2x cubed, isn't it? So we write that up there. See, notice the lining up the cubic terms. Okay, and then 2x cubed times by 2x plus 1 gives us 4x to the power of 4 plus 2x cubed. And then we find the difference between them. This subtract this, obviously 0. This subtract this, negative 2x cubed. And then we bring down the negative 17x squared. Okay. If you did have a go at it and you got it wrong somewhere, then hopefully you'll be able to see where it is. Okay. When you're doing it by yourself and you're checking the answers in the back of the book and you get it wrong, it's kind of hard to find. But what you have to do is you have to plough through your word, almost go through it all over again, okay, for a second time. It's difficult to spot, okay, but usually it's in the negative values. Okay, right, let's have a go at the next bit. So we've got to do 2x, what times 2x gives us negative 2x cubed, and it's going to be negative x squared. So then we do negative x squared times this, which gives us negative 2x cubed, subtract x squared, okay? And then we find the difference between them. So we do this, subtract this is 0, this subtract this gives us negative 16x squared, okay? And then we bring this down, bring down the plus 0x, and we start all over again. So 2x multiplied by what gives you negative 16x squared? So the answer is negative 8x. And then we do negative 8x times all of this. So that's negative 16x squared. Subtract 8x. Find the difference between them. That subtract that is 0. This subtract this gives you positive 8x. Bring down the plus 4. And then do it again. 2x times what gives you 8x? It's 4. So that's plus 4 there. And then 4 times this gives us 8x plus 4. And then find between that 0, which means we're done and there's no remainder. Okay. So our answer to what you get when you divide this by 2x plus 1 is that. Now I'm going to write it another way for you. Okay. You can write it as 4x to the power of 4. Subtract 17x squared plus 4 divided by 2x plus 1. Okay, and our answer is 2x cubed minus x squared minus 8x plus 4, like that. Okay, so basically what we've done is we've simplified this algebraic fraction, if you're writing it this way, in order to get this. I'll write it one final way for you. So starting with the quartic, 4x to the 4 minus 17x squared plus 4. We can write it as 2x plus 1 as one factor, and the other factor is 2x cubed minus x squared minus 8x plus 4 as the other factor. So just a reminder there that this long division process helps us with factorising as well. In other words, if we know that 2x plus 1 is one of the factors of this, we can do the long division process to find the other factor, okay, and it's this, okay. The fact you get no remainder there means that it divides exactly and you get a perfect factor, okay. So just a reminder, factorising is another useful tool that we need to be able to do sometimes when dealing with algebra, isn't it, okay. Well, I hope you found those examples useful. Next thing to do is just practice. Practice as many as you can, okay, because this is extremely important stuff, okay. Right, hope you enjoy that. Have a good day.